Happy Friday, Baylor College of Medicine and friends of Baylor. So lots to talk about this week, and we have two major issues. My sister wants to know about what's going to happen going forward, and so a little bit of a teaser. I have had a discussion with Lily, and she has her 5-point plan about how to get rid of this pandemic, which I will go over later. And then I've had a bunch of people ask me about variants of concern, which are really it's a really boring topic, but we're going to try and make it less boring. So I'll start off today with just talking about updates on vaccines. We'll look at variants from 30,000 feet. We don't want to get too close to them. We'll look at how we're doing as a country and locally, and then the Lilly 5-point plan to get out of this craziness. So lots of good news or interesting news at least, on the vaccine front. Pfizer just got results from its pivotal trial for children between 5 and 11. They used a 2-dose regimen of 10 micrograms, administered 21 days apart. For the adults, you'll recall, or you may not recall, it was 30 micrograms, so it's 1/3 the dose. And we talked about they had to go through that process before they could really, determine the right dosing. That was picked because of safety and tolerability. And the good news is that the antibody responses in kids at that dose was comparable to the antibody responses in adult or teenagers and adults from 16 to 25. So that looked like a really great response. They're submitting that to the FDA and other regulatory agencies. And my guess is that that'll get approved fairly soon. So great news for parents. The result on the children under 5 is also expected pretty soon. But the good news is it looks like the Pfizer vaccine, at least at 10 micrograms, at that dosing regimen, is safe and effective and tolerable. And thank goodness parents finally have a way to manage their children going to school. Also, a big update from Johnson & Johnson. They just finished their phase 3 trial that showed that there was a dramatic improvement with an extra dose. So they looked at hospitalizations and death based on the Ensemble 2 study. It was a phase 3 randomized trial. It showed 100% efficacy against severe critical COVID and 94% efficacy 2 weeks after the second booster shot. Remember, Johnson & Johnson was 1 dose. That began to fall down in terms of symptomatic infection from 94 to 74%. So they did this study to look at a second dose. The interesting thing was the timing. So they got a 4-fold increase in antibodies when the second dose was 2 months after the first dose, and they got a 12-fold increase when it was 6 months. And so it kind of shows you the importance of spacing with the booster shot. One of the things with the Pfizer, remember, it was a little bit quicker, a little sooner than the Moderna, so that may have also had an impact. And then, of course, the big news on the booster front, the Pfizer vaccine reduced the risk of hospitalization. It was 91% in the first 4 months, but it had dropped to 77% after 120 days. A booster brought it back up to 95%. Moderna has been 93% at reducing short-term risk of hospitalization, and that remained at 92% after 120 days. And that's the reason the FDA decided to go ahead and approve the booster for Pfizer. So that's great news. That'll be approved for those over the age of 65 and after 8 months. It's interesting to figure out why are they different. The dose of the Moderna vaccine is actually 100 micrograms of vaccine. That's 4 weeks apart. And the Pfizer vaccine is 30 micrograms. So it's about 1/3 the dose, and it's also closer together. And as you saw from the J&J vaccine, spreading them out a little bit farther probably helped with the booster activity. Anyway, so let's spend a little bit of time, not a lot of time, talking about the variants. So the structure of the coronavirus is interesting. It's, an RNA virus. It has about 30,000 nucleotides of RNA, and it forms these spikes all over it. And those nucleotides encode a sequence for proteins. And the proteins that most people look at when it comes to mutations is the spike protein. So just when you think about these viruses in general, a group of coronaviruses share a bunch of distinctive mutations, and when they become clustered together and they're distinct in terms of function, then we generally refer those as variants. once they really have functional differences rather than just genetic differences, we call them strains. And so if you think about COVID-19, it is caused by a coronavirus strain known as SARS-CoV-2. So it's another coronavirus that has developed a separate strain. And over the course of the pandemic, a number of variants in SARS-CoV-2 occur, and that usually is we look most in the spike protein because that's the business end of the virus. And that spike protein is comprised of about 1,273 amino acids. And together, when it's produced, it forms a trimer, and that trimer, the three proteins stick together. So it's three copies of the spike protein as a complex, and that becomes the spike that sits on the top of the viral capsule. And the way we refer to mutations is the individual mutation is indicated by the location along that 1,273 amino acid chain, and then what the amino acid substitution is. So for example, the first mutation that I want to talk about is the D614G spike mutation that emerged in eastern China at the beginning of the pandemic. And the way the mutations are referred to is there's a substitution of aspartic acid by glycine at position 614. And that's how all these mutations are referred to. And what was thought about that particular mutation is it made the virus much more infectious. So it became the dominant strain in China. It became that mutation was present in Europe and in the USA. And it's so widespread now that all of the different mutations, all the different strains and variants have that mutation. And so we really don't talk that much about it because they all have it. So what becomes a variant of interest? It's if there's some genetic changes that seem to be likely to produce a change in transmissibility or severity or immune surveillance reduction or changes in diagnostics, that becomes a variant of interest. But it has to also have clustering. So you see multiple clusters in one country or clusters around the world. That becomes a variant of interest. What makes a variant of interest a variant of concern? Well, when you actually show that it has increase in transmissibility or an increase in virulence or a decrease in the effectiveness of public health strategies or in diagnostics or, for example, escaping the vaccination. So that changes from variant of interest to variant of concern. And the major variants of concern are the alpha variant that was identified in the United Kingdom, beta that was identified in South Africa, gamma in Brazil, and delta in India. And so when you think about all these variants of concern have multiple mutations. And I already talked about the D614G, but the other one that's very prominent is one called N501Y. Same kind of thing, arginine substituted by tyrosine, that's the N for the Y for the N. And that arose independently in many of these different lineages, and it's present in alpha, beta, and gamma. And that's an example of sort of convergent evolution where there are all these mutations, but they all seem to develop this particular one because that mutation seems to change to the shape of the protein that binds to the human receptor, and so it's much more tightly bound and makes it more infectious. And the other major mutation that many of these variants of concern share is the E484K spike mutation, which scientists refer to as EEK, because it's EEK. And that's in beta, gamma, and alpha, and that one occurs right at the top of the trimer, right at the top of the arms. And because of that, anything that changes the shape of the spike protein potentially makes it more difficult for the antibodies to recognize it. And so that's another one. And there are three other major mutations that are seen. We don't really know what they do. It's not clear all the time. Some might be improved binding to the receptor. Others might make it easier to enter the human cells. Others may make it easier for the number of spike proteins to be produced. But they're all there, and they're in various amounts in the various variants of concern. So let's just take the major variants of concern. Alpha, I mentioned, was isolated in the United Kingdom. It's about 50% more infectious and also thought to be 30% more virulent. In other words, it causes 30% more disease. It has that N501 we spoke about that helps it bind more tightly to cells. It has many other mutations, ones that probably impact the ability for it to make more spike proteins, and another one or two that involve shape changes that might allow it to evade your antibodies. The beta variant, first isolated in Africa, South Africa, there's a number of clinical trials that have shown that particular one evades the immune system better. So, vaccine trials that are done there are usually not as effective as vaccine trials done in other parts of the world. And that also has the N501Y and several other, the EEC mutation. You can see the recurring theme. They have multiple combinations of these various mutations that allow them to either be more infectious or evade the immune system. There's the Gamma variant that was first isolated actually in Japan, but from people in Brazil, and then it was found to be the main one in Brazil. We talked about this last week in Manaus, Brazil, in Amazon city. They had a huge outbreak. 70% of the population got infected, and then it dropped because they really achieved herd immunity until this Gamma variant emerged, and then they had a giant outbreak again. And it's very similar, actually, to the South African variant, but it has the EEC and the 501, all these same mutations, but it has additional ones as well. And then the last one is the Delta variant. That one emerged, they called it a double variant for a while because it was Delta and Kappa together, but they split because the Delta virus developed a bunch of mutations that actually are seen in many different variants around the world. And Delta became the fastest growing one, and as you now know, Delta is the major one worldwide. So that's kind of a summary of all the different variants and how we look at them as they evolve and emerge over time. So how are we doing? Well, things are about the same. The U.S. is not doing very well. The same hot spots are the same as before. But the main thing I want to point out is, just in reality, we're just not doing very well. That's the United States compared to the other rest of the countries in terms of number of cases. And, if you look at in our country right now, we finally have plateaued. I think we're probably at the plateau, but it's a high plateau. And we have 55% of the country is fully vaccinated, but only 64% have had at least one shot. We talked about herd immunity last week. You have to get to 85% or more before we'll see this thing begin to decline. And we've now reached a new milestone, 678,000 deaths. That's more than the Spanish flu, 1918. I mean, have we not learned something in 100 years? We have the means to fight this, and yet somehow we don't. And there's a huge outbreak, of course, now in Tennessee, Kentucky, West Virginia, and now somewhat in the Northwest. Even my friends in Custer County, they used to have no cases. They got several cases now. And this is the most disturbing from a public health perspective. This is the vaccine density. So this should be dark green. And where it's light green, there's fewer population is vaccinated. And the main thing, it's just so variable. And again, when we talked about herd immunity, the importance of it being homogeneously 85%, we're nowhere near that. So there's no consistency for vaccination around the country. If you look at public health measures, where masks are mandated for school kids, that's the brown. Where masks are banned, mask mandates are banned, is dark brown. It's variable for light brown. I mean, it's just that there's no consistency in public health measures, and there's no consistency in vaccination. So, how do you deal with that? So I'll use my friends in Dimmitt County. I love Dimmitt County. As I said, I'm going to move there. They were a mess, right? I was making fun of them, but I was just reporting they were the worst in Texas for the longest period of time. Well, you know what happened? They now have 98% of their population has had at least one vaccination, and the county school system put in a mask mandate. And guess what? They're one of the least hot spots now in the state of Texas. Meanwhile, Harris County, we're all very sophisticated here. We have all these medical centers. They have fewer cases per 100,000 now in Dimmitt County than Harris County. I mean, just think about that. I mean, a month ago, where we had pictures of the javelinas running wild there, and everyone's infected, and now they're head of the Texas Medical Center. And I wonder what it is. It's 98% vaccinated and mask mandates at school. Well, here in the Texas Medical Center, we're finally seeing case numbers come down and hospitalizations come down. But even this past week, 271 per day hospitalizations. It's coming down, but it's not coming down fast enough. So let's go back to our projections. IHME, the Institute for Health Metrics and Evaluation. This is really interesting and a little bit disturbing. Currently, based on the fact that we're not really making much progress on vaccinations as we should, Based on the current vaccination rate, this is where we plan to go. That means it's just going to stick around here. We have millions and millions of people in this country who are still susceptible, not vaccinated, and they will continue just to churn. And by the way, even adopting universal masking, which of course no one agrees to, it gets it lower, but it doesn't make it go away. And I just show you, if we're able to achieve herd immunity by having 85 or 90% of the population immune resistant, either because they got it and recovered or because they got vaccinated, it would drive it down to virtually none. Now you'll see in this little gray line, there'll still be susceptible people, and the virus would still be around, but it would be a very different world. So, there are a lot of reasons why, at least from my perspective, the country shouldn't be going on like this. More people have now died from this than the Spanish flu in 1918. The economy is really impacted. Our workforce is having troubles. The travel industry, hotel industry, conferences, real estate sales. There's a lot of things going on in the energy sector because there's still we haven't returned to full activity. Healthcare systems are overrun. I mean, we just got to be honest about it. Healthcare workers are overwhelmed. Nurses, we're having trouble retaining nurses. The nursing field, I hope, recovers. Rural hospitals are really overrun. Our kids are now entering the third year impacted by COVID. Because 2019 at the end of the year, 2020, 2021 now. And so, I get frustrated. So I ask, I don't know what you do when people don't listen to scientists and don't follow the recommendations. So I did the only thing I know, ask a reliable source, Lily. Because Lily knows all things that humans don't know. So I said, what do you think? And she said, well, look Scotties are notoriously anti-vaccine. They don't like to share information about their proof of vaccination. But when they go flying, they got to show their proof of vaccination. And so she said, I think there's something we can do. The dogs can lead us to the right thing. And also, as in the words of Bruce Buffer, it's time. We've got to start doing something. So here's the Lilly 5-point plan to end the pandemic by March of 2022. So the first thing is, airlines should require proof of vaccination to travel. Now, I think the CDC could help us by creating an app, that puts your vaccine type, vaccine dates, and I think it should be linked to your license, your driver's license, so that states eventually could link their databases to the CDC database, and you could use your driver's license once again to have proof of vaccination, just like you do proof of organ donation. It can be linked to your driver's license. Eventually, the TSA should be able to make this all work. I think schools should require vaccination now that kids will be soon to be eligible. I think unless there's a medical reason for a kid not to be vaccinated, they should make kids. And by the way, kids need to wear masks, and people in airlines need to wear masks all the time until we get to that 85% or 90% of herd immunity. People outdoors, kids outdoors, they don't need to wear masks, but right now it's a real problem. Personally, I think restaurants and bars or anywhere where you cannot wear a mask should require proof of vaccination. Unless they want to eat outdoors, drink outdoors. But indoors, if we want to get rid of this, we're going to have to start looking at proof of vaccination. And the one that really bothers me is essential services like grocery stores, pharmacies. We should just be mandated that everyone has to wear a mask indoors, because we can't expect the grocery store owner or the employees to be enforcing those kinds of rules. And people who need essential services, we don't know who's vaccinated, who's not. So I think that's part 4 of it. And then the last thing is, when 85% of the population is immune from either because they were vaccinated or they got it and recovered, then we can reassess. Maybe then we can get rid of all these mandates. But until we do it, unless we get serious about this, we're going to be living with this virus infection for a long time. And of course, even when we do this kind of stuff, there will be variations in communities. There will be communities that don't get vaccinated and don't care if they travel on an airplane or not. They will continue to have outbreaks until they're all infected and have recovered or have passed away from the virus. So It's time to get serious. I'm getting sick of this. I might forget what number we're on, but it's time for us to really start having federal mandates on this stuff because the states aren't doing what they need to do. So I think a federal mandate, at least around air traffic travel, would be great. So I want to finish with some shout outs. This week is the National Postdoctoral Appreciation Week. Nobody appreciates postdocs. So nationally, we created a day to appreciate them. And we have actually 600 postdoctoral trainees across the basic science and clinical departments. And they help us do what we've got to do. They help all the labs, they help all the clinical research. So the postdocs are critical for what we do. We do appreciate you, even if no one else does. We do. I'm really excited that Ray Martin, our PA student who returned from the Paralympics, came by to visit and show me his medals. Very excited and very proud of him. Congratulations, Ray. And the last thing I want to do is thank you and Gwen for the vaccine champion pin that you gave with Lily. She got a cute little thing that you can wear this I support vaccination. Lily, as you know, through her 5-point plan, is a big fan of vaccination, mandatory vaccinations, and so she was happy to get that. So I look forward to hearing from you. I know many of you will disagree with Lily. Remember, this is Lily's plan. This is not my plan. So if there are any things you don't like about it, I will be happy to forward your complaints to Lily. Anyway, I can't wait to see you next week.